Welcome back to the series. In the last video, we explored the concept of embeddings, how they transform text into numerical representation that capture meaning. Now we're taking one step further and actually use those embeddings to make our model retrieve and reason over real data. So in this video, we'll build a simple retrieval augmented generation or a RAG pipeline, a system where the model doesn't just rely on its internal memory, but instead looks up relevant information from external sources before giving an answer. So we'll break down step by step. The first thing we do here is load a document using a TextLoader class. So it's a straightforward way to bring in external data, for example, a text file, a web page, or even a PDF. Here, we're going to use a TXT file, which might contain note, research summaries, or articles. Next, we use the recursive character text splitter. Now, this is a very clever tool. What it does is it breaks large text into smaller manageable chunks, usually around 500 characters each in our case. But why do we do that? We do that because language models and embeddings work much better when the text is short and focused. So by giving them the bite-sized chunk with slight overlap, we help the model preserve the context while avoiding cut-off issues, especially useful when dealing with large document or books. Now, once the text is split, we move to the embedding step. So here we're going to use Google's Gemini embedding model. Each of these chunks will be now converted into a vector or embedding, just like we saw in our last video. Now these embeddings need to be stored somewhere efficiently, and that's where FAISS comes in. So FAISS stands for Facebook AI Similarity Search, and it is a powerful open source vector database that allows us to store and search documents very quickly. So using FAISS, what we do is each chunk of our content is embedded into a vector, and then those vectors are stored in a FAISS index, and FAISS prepares itself to find the most similar vectors whenever we search. Then we'll go for something called a retriever. So what happens in a retriever is it is like a search engine for our AI agent. So when we provide a query, for example, like what are the key takeaways for our documents, the retriever searches through all those embeddings inside FAISS and then returns the most semantically similar search. So this step ensures that our model doesn't try to remember everything. Instead, what it does is it retrieves the right information on demand. So after that, we combine all of those retrieved text chunks into a single string of context. This context acts like the background material or notes that we pass to our language model. Then finally, we initialize our Gemini chat model and manually construct a prompt that combines both the context and the question. So when we pass this prompt to the LLM, it uses the provided context to generate a factual, context-aware answer, and then not something made up from its internal knowledge. So this workflow is the backbone of what's known as Retrieval-Augmented Generation or RAG. Instead of letting the model guess or hallucinate, we ground it with real retrieved data here. So the benefits are huge. The model gets more accurate and reliable. It can also handle custom data sources, and it's far more scalable since we can swap documents, add new data, and then do something like that. So in this video, we will take a big step from embeddings to retrieval. Now let's go to the code. So I'm going to create a new folder here and call it rag or basic rag for now. Let a new file, basic rag.py. What I'm going to do is I'm going to create a docs.txt file and then bring some paragraphs of content here. I already have it. So I'll have this content about AI. I'm going to do word wrap. You can bring anything else that you want here. It's fine. So yeah, this is my document for now. Okay, we'll go back to our basic RAG model. So I'm going to generate my model first, and then .env. I'm also going to load a text loader from LangChain community. Then I'll have a text splitter from LangChain. Then let's also import our embeddings from Google Gen AI. Then we'll use vector stores to store our embeddings here, and then we'll use a retrieval QA. So from LangChain chains put retrieval, not this one, retrieval QA. Okay. Now based on this, first let me load the credentials. Load the credentials. Okay, I'm providing stepwise information here. So step one, I'm going to load my credentials. In step two, I'm going to load the document that I have. So I'll be defining a loader and then using this class here called TextLoader. My file name is docs.txt, and then I'm going to load this. So documents equals to loader.load. In step three, I'm going to split the text into smaller chunks. So for this, I'm going to use a text splitter, recursive character text splitter. I'm going to define the chunk size of each splitted text. Let me give 500, and then also chunk overlap, because we might carry some contextual information in while breaking the chunks, so we want some overlap so that uh, two different chunks can have something in common between them. So I'm going to split my document using this splitter. So text splitter dot split documents. Okay. Now I'm going to, okay, this is step three. I'm going to step four, where I'm going to convert text embeddings and store in FAISS. So here what I'm going to do is I'm going to define embeddings equals to Google Generative AI Embeddings, where the model is model slash Gemini Embedding 001. I found this in the LangChain documentation itself. And then I'm going to define a vector store using phase dot from documents from documents docs comma embeddings. Then in step 5, I'm going to create a retriever which fetches relevant documents. Okay. A retriever equals to vector store dot as retriever, and then I'm going to initialize a model. So model equal to chat Google Generative AI, model equals to Gemini 2.5 flash. You can even use Hugging Face models here. Step 7, I'm going to create a retrieval QA chain. So chain equals to retrieval QA dot from underscore chain underscore type, where LLM equals to LLM and a retriever equals to a retriever LLM or model here. Then I'm going to manually query the model and retrieve relevant documents. So query is going to be like, okay, what is the document about? Let's see. So it is about AI. So my query will be very simple. So what are the key takeaways from the document? And then based on this query, I can invoke my chain here. So chain dot invoke query, and then finally I'm going to print my answer. So print response. Okay, the code is done. I have tried to provide you stepwise implementation of what we talked about in the rack pipeline. So let me run this. Let me also save this document and then run this here. So the model will provide answer based on, okay, I need to install something here. So FAISS CPU needs to be installed. Let's write it down in requirements.txt too. FAISS GPU, install this, install -r requirements.txt. Okay, we can install the CPU version because my laptop not be equipped with GPU here. Okay, so let me run this once again. And while this is being run, the answer from the LLM is based on the documents that I provided and not on its internal knowledge base. So the key takeaways are like actually provided here. If we need to ask something specific from this document, like what is this? So doing such tasks such as learning, reasoning, AI comprise a very okay. What kind of technology that AI comprise? Let's ask that. So what kind of technologies does AI comprise of? So if you ask this question, then the model is going to provide the answer based on the document and not its internal knowledge. So it says AI comprises a variety of technology. It's copied just from this particular context here. So this is how we build a basic RAG pipeline. I hope you understood the concept. If you have any question, feel free to comment down below and I'll try to help you out. And I'll see you in the next video again.